Hello and welcome to episode 147 of our SAP on Azure video podcast. Today is June 15th, and together with Robert and Goran, we're here to talk about anything related to SAP and Microsoft. Hello, everyone. So in a lot of cases, running your SAP system on one of our virtual machines is perfectly fine. You can have small certified HANA VMs with a few hundreds of gigabytes of memory only. Or you can scale up to virtual machines with almost 24 terabytes of virtual memory. However, there are scenarios where it makes more sense, or maybe where it's also required to scale out. That's where we can reach terabytes regions that go way beyond 24 terabyte. In order to take a closer look at these scale-out scenarios, I'm happy to have Abbas and Momin with us today, who will walk us through this setup. But as always, before we hand over to them, let's quickly take a look at some of the news from this week. And I actually want to start with an announcement from SAP that now the ABAP environment on the Business Technology Platform is also available on Microsoft. So if you're running BTP on Azure, maybe because you also have your SAP system running on Azure, then now in the Business Technology Platform, you can also use the ABAP environment, so Steampunk, directly on BTP. And obviously, you can use this to build, extend, and integration scenarios with your SAP system. It's available in all the BTP on Azure regions, and it's certainly good to test this out and give it a try. Actually, if you want to give it a try, then our own Martin Pankratz is again very, very busy and is creating a blog post series on how to leverage this ABAP platform on BTP on Azure with your SAP systems. So he has started here the series where he's talking about how to get started. So basically referencing to existing videos and tutorials that help you to get started with Steampunk on BTP. But then, and that's now really the cool thing, going into some new scenarios. So how you can use this in combination with Excel, how you can use this with the API management. So stay tuned. There will be some really cool new scenarios. You probably know Martin. He's very diligent when it comes to this. There will be lots of explanations, a lot of details how to get started and how to use now ABAP on BTP on Azure in combination with your SAP system. Now, speaking of Martin, there was the Integrate conference last week, basically in London. It was a 3-day event, and there's a lot of content that was presented. So a lot of integrating content, obviously, with Azure integration services, how you can leverage them to connect different Azure services and non-SAP and Azure services together, basically. And Martin actually also attended Integrate, and he had a very nice session about using is it this one? Sorry, about using the Azure API management, using the Cloud SDK on the SAP system. Wait, where was it? I had it prepared, but now here it is. Here it is. Sorry, here. Crush SAP application integration lead time with Azure, where we really talked about how to use the Azure services to connect to an SAP system using an OData service. So it was a really nice session. I mean, I wasn't there, but he shared some of the content with me up front. And I hope that we can invite him also to the podcast in the near future, so he can also repeat his session, or at least some of these things on our podcast. But it was a really, really nice flow that he outlined there. Next, Azure OpenAI. I mean, we wouldn't be in the right time if we wouldn't talk at least mention once AI in our podcast here. The Azure OpenAI services are now also available as a SAP Private Link service. So remember, with the SAP Private Link service on BTP, you can connect services on Azure with your BTP environment if everything is running on Azure without actually exposing services to the public internet, which obviously from a security point of view can make a huge difference. And now this list of private link services I think we have now 11 or 12 services, and one of the latest services that we introduced is now this Azure OpenAI services. So if you want to develop some scenarios using Azure OpenAI, if you want to maybe build an SAP Fiori application or something from your CAP application and connect to an Azure OpenAI service, you can now also do this via Private Link. And speaking of OpenAI or AI in general, I just want to recap. There was a blog post actually published a month ago, but I think it was a really nice blog post from SAP where they talk about their approach on the AI built for business. So basically, they are offering on the business technology platform or in general on SAP in the context of AI. And I mean, you probably have seen during, and we talked about this during the Sapphire. There, for example, was this SAP SuccessFactors recruiting scenario where they showed how to combine SuccessFactors with Microsoft 365 Copilot, where from SuccessFactors we could create using Word a new job profile there using the AI capabilities. So you can see that yes, this is a Microsoft an SAP service that they are offering, but under the hood there are a lot of Microsoft technologies, a lot of Microsoft AI services that are being used. And this blog post here goes through a long list of different what is it called? Business AI services from SAP that will bring, not all of them are available obviously yet to customers, but you can see where this where SAP is going with this. And obviously on the Microsoft side, we are working very closely with SAP to realize a lot of these scenarios. And speaking of summarizing some of the AI services, I again also want to redirect you to one link here. So this news.microsoft.com, reinventing productivity. And I just think I just spent another few hours watching some of these videos. This is really a beautiful consolidated view of a lot of the things that we are currently doing on the Microsoft side. Granted, it doesn't have anything to do with SAP, but it shows some of the potentials that I think will really get more and more concrete as time progresses. So talking about Copilot in Excel, Copilot in Outlook, and Word, in PowerPoint, and so on. So I think it really shows already the potential, the upcoming potential of leveraging AI in Microsoft services. So with this, that was the quick news update. Now let's head over, or let's continue, and let's introduce Momin and Abbas. Maybe you can quickly introduce yourself. What are you doing at Microsoft? And yeah, then let's get started.
Sure. My name is Momin Qureshi. I come from Microsoft Engineering on the CSI team, and I'm based out of Atlanta, Georgia. And really, I specialize in SAP workloads, bringing on SAP systems onto Azure, everything from performance tuning, backup, full end-to-end migrations, and after migrations, all the hypercare and care and feed of the system. So I'm involved end-to-end to all the migrations. I'll pass to you, Abbas.
Thank you. Hi, this is Abbas Mir. Hello, everyone. I'm a principal SAP Cloud Solution Architect at Microsoft, and I've been, covering some of the very large enterprise customers. We are doing a lot of the heavy workloads with SAP on Azure. The thing, it goes from high availability, disaster recovery, backup and recovery to fine-tuning the environments and whatnot. So yeah, look forward to this session.
Perfect. You know the ins and outs. Perfect. So before we go into the actual details, Momin, in the preparation, you shared something with me where I really had to smile, because in the past we had Ralf Klar with us on the show, and one of the things that he started with was always a recipe. So when you shared the content, obviously the topic of today, basically, you also shared this with me. So can you talk a little about your recipe?
Yeah, first off, Ralf Klar's a good colleague, mentor, friend, but we could not have him outdo us. So we have to bring our own recipe here. So this is an easy tandoori chicken. I have pretty much no cooking skills, but this one lands. So definitely go to your local Indian store. There's many prepackaged tandoori mixes. Mix that into some chicken. I like to put garlic, some onion powder, ginger, to your liking. I don't measure anything. I just sprinkle stuff on. And then get it on the grill, 300 degrees, 45 minutes one side, 45 minutes on the other side. It can be served with naan, rice. If it's too much heat, you can put some yogurt or raita. And this has made me a local hero and legend in Atlanta barbecue. So definitely encourage everyone to try this on the weekend.
Fantastic, Momin. Thank you so much. And I'll definitely give it a try sometimes.
Absolutely.
Perfect. So now that we're all hungry, let's be hungry for some technical news. So Abbas, over to you. I think you have prepared also a few slides. And then let's see.
Yeah, we'll share the slides, and I think Momin, you want to cover?
Yeah, if I can start off. First of all, Jose, thanks for inviting us on the podcast. Always enjoy watching it because sometimes reading documentation puts me asleep, but the podcasts keep me pretty inspired and motivated. So thank you for all the legwork that you do on that, and thank you for inviting us. So appreciate that. So we're going to talk about high availability scale out architectures in Azure, and really we run two architectures in Azure. We have one that's a HANA scale out with a standby node. We also have another N+N architecture. But one thing I wanted to start off with a little history, and those of us from the R3, ECC environments, we never even heard about HANA. And then when HANA came out, it was really this amazing technology. And then this scale out stuff came out, and we're like sort of blown away that what is this? This is something really foreign to us, right? But that's not the case anymore on Azure. I see so many scale out environments, and it's not just like 2+1 or smaller environments. We're talking about 8+1 or many large environments, and they're very performant and they run. It's really a proven, time-tested architecture now. So definitely just wanted to bring that up. So I want to walk you through this HANA scale out with standby architecture here. Now, whenever we run standby nodes in Azure, we have to use Azure NetApp files. And on this, we can see on this first VM on the left, I'm calling that the master node. The middle VM, I'm calling the worker node. And then we have in gray the standby node. And the way that HANA works is that if there's an issue, let's say with the worker node, or failover, and activate the standby node will take data from the persistent layer and bring it into memory, and then you're pretty much operationally ready. A little more about this architecture, that you can see the volumes on the bottom, the HANA data, the HANA log, the HANA shared. It's all mounted across all three of these volumes. 3 VMs, sorry. And a little bit about the NICs here. There is the HANA database client NIC that is traffic to the app servers. There is the HANA, the middle NIC, which is the internode connectivity of the VMs. And then there's this database storage, which is talking to the ANF. And that will be, this was the first workload I deployed actually using this link, and it's very detail oriented, step by step, and it actually gives the test case scenarios as well. So it's a really good link. Boss, if we can move to the next slide. Sorry, Jose, did you have any questions about the first slide?
No, all good, all good. Thanks.
Oh, good, okay. So a little about this N+N architecture. One thing you notice that this is a zonal redundant architecture. In the first case, we'd have one zone, if there was some flooding or power outage or something, we'd sort of be in a soup in that specific architecture. Here we have multiple zones. So you can see zone 1 has a master node and 2 worker nodes. Zone 2 has a master node and 2 worker nodes. There is, you see a VM in the middle, which will actually be in zone 3. This is the majority maker. And this is used for pacemaker, that all these nodes are controlled by pacemaker, that if there is an issue, let's say with any of the nodes in site 1 or zone 1, pacemaker will fail it over to zone 2 or site 2, and vice versa. If there's an issue in zone 2 or site 2, pacemaker has the intelligence to fail over to zone 1. The databases are kept in sync using HANA synchronized replication. I'm going to pause for 1 second. Hold your boss on. I want to ask you, what are your thoughts? What do you think compared to the standby environment and this N+N architecture? What do you think is an advantage or disadvantage comparing those two architectures?
So on the previous architecture, if you go in here, the advantage of this architecture is more cost effective, because you need to have less number of nodes to keep it up and running. The other thing is, you don't need to have additional nodes just for HSR application. But the challenge with this architecture is that it will have a reduced RTO, because whenever one of the nodes goes down, you have to bring up this node, and the database has to come up online. So you're looking at a longer RTO for you to kind of go with this one. So more cost effective, reduced RTO for this architecture. On the other architecture, if you look at it, it's going to be more expensive, because you've got to have like for like nodes. Like if you have a master and 2 worker nodes, you'll have to the same amount of number of nodes on the other zone. But then this would fail over with less than 15 minutes. So very, higher and improved RTO, if you will, on this architecture, but less cost effective, or in other words, more expensive.
Excellent. Yep. Oh, fantastic. And Abbas only knows this because we implemented this at multiple customers. Just
both of architectures have been implemented at other customer sites.
Absolutely. These are production-proven large enterprise customers running these architectures. So just to finish up this architecture, that there is each VM has 3 NICs. Once again, a client NIC for application traffic, internode NIC for VM traffic, and then we have a HSR NIC for replication from site 1 to site 2. One thing interesting here is you'll see, once again, no standby nodes. You also see that the HANA data and HANA log are on managed disks. So with the standby node, we do need ANF or NetApp files. And then for this architecture, you can use ANF or you can use managed disk. One caveat being HANA shared, and this architecture was ANF, just due to the fact that HANA shared needs to be mounted or shared between all 3 nodes.
Good point. Yeah, interesting.
Yeah. It is,
so in the previous slide, it was everything based on ANF, and here we are really using okay, interesting. Okay. And just for everyone to understand this zonal concept, this is all within one region. So this is still, let's say, in Western Europe or some region in the US, obviously, or anywhere across the world, but in really dedicated data centers. So the zonal deployment really makes sure that these VMs are not sitting next to each other, that they really have their own dedicated power supply and so on, so that in case one data center goes down, the other data or the other zones are still up and running, and that's how I can have this high available setup here.
Absolutely. I almost want to say, back in the on-prem days, we used to use like a metro DR, like an in-region DR, and then we have an outer region DR. So you almost, you have that extra layer of protection. Additionally, these links that are in the podcast, I've vetted both of them really good. I encourage everyone, even if you don't know much about Azure, you can really follow it line by line. It shows you how to install the HANA node, the worker nodes, and then it'll also give you test cases where you can, use this command to reboot the VM, crash HANA, and you can actually see how this behaves and look in Studio and look on the OS and really understand the concepts of these scale-out architectures. So from there, Abbas, I'm going to pass it on to you. I know you have some slides and we can bring up a demo.
So real quick, I think as I continue on this one thing I do want to mention the difference between the two architectures, and I think Nicole, you did bring up a good point earlier. So this architecture is confined to be deployed within a single data center in a single zone. So if the data center had an outage or the availability zone had an outage, then this environment will not be available to you unless you the data center and the availability zone is brought back online. So this is confined to a single data center. So yeah, while this has rack level or node level fault tolerance, it does not have a data center level resilience. So if data center goes down, you would be down with this architecture. Versus in this architecture, you not only have data center level resilience, but you also have a zone level resilience. So whether a node goes down, or a physical rack goes down, or a data center goes down, or an availability zone goes down, you still will be able to fail over within 15 minutes and be operational on the other side. And that's the advantage of going with this architecture. Now, our documentation has these two links. We talked about the previous link talks about an N+1 architecture with an ANF, and the second link talks about an N+N architecture where you have 3+3 nodes shown here with the majority maker with the premium managed disk. What we didn't have in our documentation is an N+N architecture with ANF, and that's what this demo is really trying to kind of explain to you how we have done it. And any customers who are wanting to go forward with this architecture can take advantage of this podcast and follow through. So and that's where this thing comes in, where we really are now showing the same exact N+N architecture, where we've got the 3 nodes on the left as part of the HANA Site 1, and we have the 3 nodes on the right which are part of the HANA Site 2. And each of these HANA sites have a master node and 2 worker nodes. And then we have the majority maker, which really helps you establish the quorum. In a pacemaker cluster, if there is a more than a 2-node cluster, you need to follow an n/2+1 rule. So you need to have a minimum of 4 nodes to be able to establish quorum. Keep in mind the majority maker is not a single point of failure here. If the majority maker is down, you still will be able to fail over from, say, HANA Site 1 to HANA Site 2, assuming HANA Site 1 was primary, as long as there are 4 nodes running in the 7-node cluster. So it could be any number of 4 nodes running, which will allow you to fail over. But for a failover to happen, you need to have the 3 nodes running on the other side. Let's say you're in HANA Site 1 and one of the nodes goes down here. It's going to trigger a failover to HANA Site 2, but the expectation would be that the HANA Site 2 is having the 3 nodes up and running. And the way the architecture works, even if a single node goes down on the primary side, it's going to trigger a failover to the HANA Site 2. That's one thing to note. The other important thing is in these N+N architectures is the Azure load balancer. We do use a standard Azure load balancer, which is zone redundant, and it's available across all the 3 zones. And with this one, you point to the master nodes. You do not point to the worker nodes. So we really have the master nodes in this load balancer backend pool. And what this load balancer is really doing is simulating a floating IP address that you traditionally do on an on-premises network. That's what it's doing here, where it's in essence ensuring that the VIP, which is the IP address and the port number that you want to listen to, is only active on the primary master. So if this HANA site was primary, then it'll be running on this primary master over here. And in the event of when you're performing a failover from HANA Site 1 to HANA Site 2, that VIP, which is the IP address and the port number, will actually fail over to this secondary master, which becomes a new primary master after the failover. We're going to show you those in the demo session as well. The other important thing is that in the previous slide, we talked about the 3 NICs that are attached. These are the client NIC, which allows for the app and the other client communication coming to this database. And then we have the internode NICs attached to these VMs, and the internode NICs ensures that within the HANA side, the internode communication is happening, which is like from and HANA S1DB1 to S1DB2 and S1DB3. These 3 nodes are talking to each other using the internode communication in HANA Site 1. Likewise, in HANA Site 2, these 3 NICs are actually leverage the internode NICs for the internode communication between these 3 NICs. Then we have the HSR communication. The way the HSR communication works, it's a 1-for-1 communication where the primary master is sending HSR traffic to the secondary master, and the primary worker node 1 is sending HSR traffic to the secondary worker node 1 here. And likewise, the primary worker node 2 here is sending to the secondary worker node 2 here. It's a one-to-one communication, the HSR communication. We added one more NIC over here, and that is for the traffic, which is basically from this VM to basically talk to the ANF layer. So there's a dedicated storage NIC that is created on each of these VMs, and that is using the VM is using this NIC to talk to the storage is the ANF volumes over here. And keep in mind, the ANF volumes are also residing in a dedicated ANF subnet, and they have their own IP addresses that are attached from the ANF subnet. We're going to talk through this in a minute as well. So that's the key thing in here in this architecture. And I think before we go on to a demo, is there anything? Oh, one more thing. Each of these NICs have accelerated networking turned on. Now, one of the things that customers typically ask, and rightly so, is that it makes sense to have multiple NICs in a traditional network, because then you can gain in bandwidth and throughput. When you're doing that, you can have 10 gig cards or whatnot attached to a particular VM. In an Azure world, no matter how many NICs you attach to a VM, your overall expected or allocated network throughput remains the same. It's not going to change irrespective of how many NICs you attach. So what is the benefit of having these 4 NICs here? Why not we just go with a single NIC? And our response to this is that Microsoft, when we certified this architecture with SAP, we were guided by SAP to use multiple NICs. And that was why our documentation suggests for any of the HANA scale-out architectures to use multiple NICs. And it is better to stay with multiple NICs because it helps when you're running into issues or troubleshooting, that when you're opening up a SAP ticket, then they also are looking at this and saying it's a certified and supported solution that they recommended to Microsoft. The other benefit of this architecture is that, let's say you are having an internode communication issue or an HSR issue. If you had a single NIC, it is very hard to filter out traffic which is specific for HSR or for internode. Having them as separate NICs, it's so easy for you to go into that specific NIC and look at the volume of traffic that is going in and out. It just makes troubleshooting a lot easier. And there is no additional cost of using these NICs. So I think it's recommended to use multiple NICs with this architecture. The other thing, you had some questions on this. Go ahead.
No, perfect. I was just saying, is there some documentation on this? Because in the other slides, you also had a link on how to set this up. But I just saw on the, or I guess on the other slide, there are some links.
So we are in the process of creating a white paper on this, and we'll publish the white paper soon on this N+N architecture with ANF. And once we have it, maybe in a week or two, we'll have that link provided in that podcast as well. But I think right now, what we were really trying to guide you through the process is that what we have provisioned is really mimicking this exact architecture line by line. That's what we have used, except for that whenever we use this, they talk about Premier Manage this, we have swapped that out with the use of ANF, which this earlier architecture guides you through. So it's a combination of these two architectures that we have implemented in our environment. And the last slide I wanted to talk about was the ANF. So on the ANF side of things, when you actually provision ANF volumes, there is a concept called ANF application volume groups. We're going to show you in a demo in a few minutes. What the application volume groups does is that it creates the ANF volumes in close proximity to the compute, wherever your ANF, your HANA VMs are running, because we want to make sure that the network latency is very less. And the way we do this is that we first provision the HANA volumes. Sorry, I take it back. The HANA VMs with the PPG, a proximity placement group, and then what a PPG does is that it basically enforces the networking constraint, where it ensures that everything is tied to a T2 spine, which in a sense is everything is running in a single data center co-located. So we create the HANA VM1, let's say in AZ1 and with a PPG, and it gets dropped into a data center 1. And then all of the ANF volumes that are mapped to that HANA VM1, for the first 3 nodes, in this case, we have like 3 nodes, right, in this architecture. These 3 nodes will all be part of the same PPG. And once we have that provision, and they're all running in a single data center in AZ1. So once we have these, for all of the ANF volumes that are getting provisioned for the HANA Site 1, we provide that PPG as part of the deployment of application volume group ANF volumes. And when we do that, all of these ANF volumes get co-located in the same data center.
Nice. Yeah.
And that's the beauty of that. So that we're talking less than 0.2, 0.3 millisecond latency between the compute with the ANF volumes, which really we don't want that to go cross zone or across to other data centers. We want to keep it into a single zone in a single data center. The same thing we do, we provision the the HANA VMs in HANA Site 2 first, and we use another PPG that's called a PPG2. And then we use that same PPG2 to provision these ANF volumes using the ANF application volume group. And then they all get co-located into the same data center in the same zone on the AZ2 side of things. That's how we do it. The one thing to note is that when we create the ANF application volume group for the first node, we do it slightly differently using the deploy first host steps. And what it does is that it basically creates 5 ANF volumes. It creates a data volume, the log volume, the shared, and the data backup and log backup. So these are the 5 volumes it creates for when you're deploying using the deploy first host steps. And when you're doing for the second and the third nodes, the ANF volumes for the second node and the third node, we use this add host steps. And the advantage of doing that is that it only creates the data and the log volumes for that. And it skips creating the shared, the data backup, and log backup. The reason is that we don't need these 3 volumes to be recreated again, because we are going to mount these 3 volumes, the shared, the data backup, and log backup, across all the 3 nodes. Node 1, node 2, and node 3. That's the reason we use the add host command, and we do this for the node 2 and for the node 3. We'll do a quick demo to show how those steps work. And likewise, this is for the HANA Site 1 showing on the left-hand side. And for the HANA Site 2, it's the same process. The first host, when we deploy using the deploy first host, is going to create the data, the log, the shared, and the backup and the log backup volumes. We do have that step there to mark them as secondary, and now it does that. It adds a prefix called HA dash to the same name. So it's all HA dash volumes that are created. And for the second and the third, when we mark it as secondary, it does add the prefix HA and HA, but since we're doing an add host, it's only going to create a data and log volume and skip creation of the shared data backup and log backup volumes. Now, with that, I think we will move to the next thing, which is we're going to go to the demo environment, which we have. And I think we'll start with the links first. So this was the links which Momin had talked about in the beginning. This is basically talking about the N+1 architecture here. As I said, this link, we only use this link to first, because we're in our architecture, we are using the ANF volumes. So whatever steps are there for creation and mounting of the ANF volumes is what we have used from this link in here. And we really followed everything else from the second link, which really talks about the N+N architecture here, except in this link uses the premium managed disk, and we have skipped the premium managed disk steps to use the previous link's ANF steps in here. That's all we have done, but everything else is here. So now with that, in my demo environment, one thing to keep in mind, I've used the same VM names. So whenever you see the HANA-S1, S1 stands for Site 1. So this always think of it as Site 1. If you see HANA-S2, it means the HANA Site 2. And then the DB1 is always the master node, and the DB2 and DB3 are the worker nodes. You will see there's DB1, there's the master node, and DB2 and DB3 are the worker nodes. So if you're reading as at HANA S1 DB1, it means is the Site 1 master. And if you're reading as HANA S2 DB1, it means the Site 2 master. And then we have the majority maker as MM, and then everything else, instead of the managed disk, we are using the ANF volumes. So going through my environment, what I did was, first, I created a virtual network. So I created a virtual network South Central US, and it already had some subnets, but I created a few specific dedicated subnets for my demo environment. And those subnets are listed at the very bottom here. And these are the 4 subnets I want to kind of talk about. Those are the client subnet, which basically is being used for all of the application servers and for the client communication to happen on 10.0.10./26. Then I had an internode subnet. I called it intersubnet, and this is my SID. I just use the HSO SID _ intersubnet that has my all my for my internode communication. And I then had an HSR subnet, with this, sorry, with this prefix. And this basically had all my HSR, communication flowing through this. And then I had a storage subnet, which basically was used for the VMs to be able to communicate with the ANF volumes. Then I also had an ANF subnet, which was housing all of my ANF volumes in my architecture. So these were the things I had. And then if you go to the jump host, I had a jump host which I had created, and I had a public IP address associated with the jump host where I can RDP into the jump host through my SSH manager. And then from there, I can SSH into all of my VMs. Now, as I said, the environment that me and Momin built was called HSO. And this, I'm filtering all the VMs in this RG underscore SAP underscore HSO. And this basically has, you can see that it has the majority maker VM, as I talked about. It has the HANA site VMs, which are my HANA S1 DB1, S1 DB2, S1 DB3. Then it had the 3 HANA site 2 VMs, which are S2 DB1, S2 DB2, and S2 DB3, and they're all up and running. And then when you're doing fencing, you of course use the Stoneth architecture, which is a shoot the other node in the head. And Stoneth has 2 mechanisms to fence. It can use an Azure fencing agent, or it can use SBDs. In this current architecture, we are using the SBDs, and the guidance is typically to use not 1 but 3 SBDVs so that it's not a single point of failure. And what these SBD VMs do is that they basically present an iSCSI device to the cluster members. So of all these cluster members, they're providing an iSCSI device where these SBD, these cluster members are writing to it and reading from it. So in the event of a failover, then one of these nodes, which is trying to fence the other node, will write a poison pill, which is read by the other node, and then there's a watchdog that runs on the other node that fences it. It's too detailed, I guess, for this demo, but that's how the process works. Then this is all the compute. The key thing, other thing I want to mention in each of these compute, for these HANA nodes, the 3 site 1 and 3 site 2 nodes, if you go into these nodes and you go into networking for these nodes, you can see that I have got 4 NICs attached to them. I had the client NIC here. We have the internode NIC. The client NIC, of course, is running on an IP address on the client subnet. And it has axial networking turned on as well. And this is the prime. And then you go to the internode NIC. This is again running from the internode subnet. It has axial networking enabled. We have an HSR NIC attached to the VM, which is again, running an IP from an HSR subnet, and it's axial networking enabled. Likewise, the HS1 DB. This is the one which is allowing you to connect the VM to the ANF volumes, and this also coming from the storage subnet with axial networking enabled. That's what we have on the VMs layer of things. We don't have any disk attached other than the OS disk here, as you can see. The reason being everything, the HANA, exactly, the data, the log, and the shade are coming out of the AM. So let's go to the ANF side of things. So typically, I have an ANF capacity pool, and then of course, when you're doing the ANF volumes, the recommendation is usually to use a ultra SKU, but for my demo purposes, I have a premium ANF SKU here. It has a 10 terabyte of capacity. And if you look at in this capacity pool, I have application volume groups created that should show up. I think it's refreshing. It's loading up, so it's taking a few minutes to load up. So we'll give it a few minutes, but it should come up. Okay, so I'm going to just minimize this to show here. So as you can see that I have 3 ANF application volume groups. These 3 are for the HANA Site 1, the top 3, and then the remaining 3 are for the HANA Site 2. And if I look at the first ANF application volume group, as I said here, it's going to have volumes which are not only going to be the data and log, but it's also going to have the shared, the data backup, and the log backup volumes, all of the 5 volumes. Ignore the throughput on it. This should be much more higher numbers. I'm just showing you as a demo here, but they'll have like 400 megabytes per second for data. It'll be 250 megabytes per second for log, and you can have a little bit more, 100 something for the shared and whatnot. So it's going to be much higher than this. This is just a demo purposes thing I'm showing you here, is what it is. And then if I'm going to the second and third ones here, then you can see that they only contain 2 volumes, and they are the data volume and the log volume. And likewise, the third one will have only the data and the log ANF volumes created. And then these three represent the HA environment, and this one is the HANA Site 2 volumes. And you can see here, when you're going over here, you can see that the data log, the shared data backup and log, but 5 volumes that do get created. And for the second and third, there's only 2 volumes being created here, the data and the log. And the third one also has just data and log. And real quick to show you how this you would create, let's say I was creating these volumes or application volume groups with another set called HN1. How would I do it? I will go in here, I will say SAP HANA, and I will say next. I'm going to say HN1 here, and then I'm going to just throw in 100, gigabyte here because I'm just playing with it here, 10%. And whenever you're using ANF, you do keep in mind that you definitely be creating snapshots, which is like instantaneous backups, and restores that you can do with a tool called Azure Application Consistent Snap. And we may do another podcast for that to show how powerful that tool is, because irrespective of the size of the database, you can just instantaneously within minutes do a backup and do a restore. Where typically on an average, if you're doing stream-based backups, it takes an hour for each terabyte to backup. And if a 10 terabyte database can take 10 hours to backup, versus you can do it in 5-10 minutes with AZSC Snap. But again,
actually, Ralph already showed us some of the AZSC Snap functionalities. But yeah,
awesome.
Maybe we can do a refresher.
Great. That is great. I mean, so coming back to the application volume group, when you're creating for the first node, the master node, you want to go with single host and first ID host on this one. And if you are doing the secondary master, you will click the HSR secondary in that case. But in this case, we are doing the primary master ANF application volume group. So you're going to go like this. And let's say you're doing this, you're going to pick a PPG. I'm going to pick, let's say, let me pick a PPG, which is instantiated, because right now, this PPG is the one which has my HANA VMs up and running. So I'm going to select that one. I'm going to select my capacity pool. Ignore this because it's asking that they don't have enough capacity. I'm going to select my ANF subnet, the VNet and the ANF subnet here. And then you go to the tags, and then you can go to the protocol, and you can these are defaults. And then the volumes. And now you can see here that it's actually asking me we want to update these volumes. In this case, I would maybe, I'll just lower these numbers so that I can come under. So let me do this, for the sake of argument. I click volumes. I can do this again and just make it 10. I'm just trying to go through the process, right? And then, let's do 10 just for the sake of argument. And we quickly do this here. And you can see here, and if you go to the last one, so but in reality, when you're doing it, you will actually follow the guidance that any of application volume groups. This is more to kind of, skirt and go through a demo with the limited space that we have got, or the throughput we have got. So here you can see that when I go in here, when I run this, I'm not going to complete it, but this is going to create these volumes for me because I don't have enough capacity that's doing it. But in a sense, when you run this, I should have adjusted the quota also, then would have probably gotten. But the data, the log, the shared, data backup and log backup. That's how you're going to create this when you're doing it for the primary master. If you're doing it for the secondary master, you just select the HA we talked about in that in the previous slide. I'm going to cancel this out. And when you're doing the second and third nodes, one thing, again, going back to this, the key thing is I was using the single host radio button option for these master nodes. When I'm doing the worker nodes, what we would be doing is this. We're going to go in, we're going to select this, we're going to go here, we're going to, again, let's say we're going to select HN1 here, and then let's say I give this 100 and I give this 10. Then what happens is that you select multiple hosts here. And depending on the number of nodes you're going to have in your scale-out environment. So in my scale-out environment, I've got 3 nodes, 1 master and 2 worker nodes. So in that scenario, what happens is that I would say that I am going to start my first host with 2 because that's what it's going to use for setting up the prefixes or the suffixes for the ANF volumes. And I'm going to say how many hosts I have as my worker nodes. I got 2 hosts, so I'm going to make this 2 here. So that's what we're going to do, because I'm using one master and two worker nodes, and I'm doing this for the worker nodes. So two worker nodes. I'm going to start with the prefix, the host ID of 2 here, because already my master ANF volumes are set. And if I was doing the the HSR, like if I was doing the high availability, the HANA site 2, I would select this, but then it'll automatically put the HA in there. I'm not doing it for this one, just to show you that how will I set it up for the primary worker node 1 and worker node 2. What it in essence does, it basically creates two ANF application volume groups one by one. So if I go here, it's going to ask me for the for the PPG, and I'll again select my PPG1 where my ANF my HANA VMs are running, and then I'm going to select my capacity pool. Again, it's because of the capacity, it's having issues, throwing error, but no worries. And of course, I'm going to select my ANF subnet. Everything is good. And then I go here, I go to protocols, and I go to volumes. And now, again, I'm going to just adjust these throughputs. And you can see here, it's only going to create the data and log volumes. It's not creating the shared, the data backup and the log backup volumes, which we don't need in here. So we go here, just readjust these, and then you're going to go in here. And now you can see what it's going to do is that it's basically first creating the first ANF application volume group, which is for the worker node 1, which with the HANA data MNT002 and the HANA log MNT0002. And then it's prompting you to go to next group, and that will be for the second worker node, which is going to have the 003. So if you go here, you can see that this basically has the MNT0003 and thing. And then you of course go in and you say previous group after you have validated everything, and then you can just actually create it at once you get past your missing error that I'm having because of the capacity constraints. You'll be able to actually create all groups will be enabled for you. You create those two groups gets created. Now for our demo purposes, I did slightly differently. Just so you know, what I did was for HSO, I did create the application volume groups as you saw, and that resulted in all of these volumes you're seeing over here. But the problem I had was there were so many ANF volumes that get created, and trying to give a throughput for all of these just becomes cumbersome. And if I don't give enough throughput for all of these ANF volumes, my database is very slow. Because I'm just doing in a demo environment. So what I did was I slightly tweaked it. I basically created this just to show you how the ANF application volume groups are created and how these volumes are laid out. But in a sense, all of my ANF volumes are residing in these two volumes. So I created two ANF volumes at a zonal, one in AZ1, other one in AZ2. And I created subdirectories for data, log, and shared for all of the nodes in these volumes, AZ1 and AZ2, and then I mounted them onto the directories under these volumes onto the nodes, and so that I could give enough capacity to play in my environment. Otherwise, I was having a challenge giving a capacity on these. Now, some of you may have a lot more, bandwidth in terms of what your teams may allow you to have, and you may be able to create and give that proper throughput and do it. But if you don't have that and you have very limited means like myself to run this demo, you can do this way where you can just create two volumes and be able to run it. The last thing, thank you. The last thing I wanted to show was the load balancer. As I said in the architecture earlier, there's a load balancer here, which needs to load balance between the two master nodes. The documentation is not completely clear on this. So I think I wanted to make sure I highlight this in this podcast, that you only need to load balance between the two master nodes. You do not load balance any of the worker nodes. And that's the key I want to highlight in this. So in here, you can see here, you have a load balancer that I have created as a standard load balancer, internal load balancer. It has a backend pool with two virtual machines. It has a load balancing rule and a health probe and a front-end IP. So let's go through that real quick. So in this one, if you look at the front-end IP configuration, I only have one front-end IP configuration that I have created, and that is, the HANA front-end 2, I call it. And that basically is the one which is the IP address, which when a pacemaker cluster does perform, the failovers, it always going to run from the primary master, whichever is the primary master or which one becomes the primary master after failover will have this IP address running on it. Then there is the backend pool, and you can see that in the backend pool, this is the HANA backend pool, which has two VMs, and you can see right now It shows that it has the secondary master and the primary master. So HANA S1 is site 1, HANA S2 is site 2. So both the masters VMs are part of that HANA backend pool. And then this is the health probe. The health probe is basically my database HANA instance is 03, so it's 62503 it's running on. Whatever your instance number is will dictate the port number. If it was 00, then it will be 62500 will be your instance. And as you can see, this port number also is alive and listening to only on the primary master, whichever is the primary master. So that's how the load balancer knows to send the IP address and the port number configuration, request, all the HANA requests to that particular node. Another key thing in the backend pool is that when you're configuring the backend pool, please do it with the client IP address, NIC interface, not with the other NICs. You have the internode NIC, the HSR NIC, and you have the storage NIC, but do so with the client NIC here, because that's what the request, all the client traffic is coming through the load balancer. So we need to have the client NICs over here. Last thing is the load balancing rule thing. And we have a load balancing rule which is tying all of the things together. It's saying your front IP address is 10.0.10.50. It's having the backend pool with those two HANA primary master and the secondary master. The reason you use high availability ports is that it basically uses a star configuration. We don't have to specify all of the front-end ports and the back-end ports. It basically uses the star. So whatever the front-end port you're trying to communicate on, it basically talks in the sends the traffic to the same ports in the back-end port. This HANA port is the health probe. It's checking the 62503 and deeming which node is the master from a load balancer perspective. The load balancer will be sending traffic to the primary master using this IP and the port, and whichever is healthy, this is where the traffic goes. The sufficient persistence, you can set it to none because we don't use any of these over here. The documentation is not specifically saying this, but that's what you need to set it to, is none. The idle timeout should be 30, and then we do enable the floating IP, which in a sense is what it's doing is that making sure that this IP address and port are actually being live and listening to on the primary master. So it's basically simulating a floating IP that you would have in a traditional world using an OS heartbeat. That's what it's doing over here. With that, I would like to move to the demo environment, which is a part of the demo environment from a portal standpoint, but let's see this whole thing in a configuration environment. How does it look like? So I'm on my jump host, which I had shown you earlier. And if you recall, I have a lot of these environments, but really we need to focus on this RG_SAP HSO environment. And what I've done is for each of my VMs, I have two terminal sessions I've set up. One is with the SID ADM, which is HSO, is the SID HSO ADM, and then another one with the root. So for all of my nodes, like the three nodes, the HANA S1 DB one is the primary master node, and then I have the worker node 1 and worker node 2 as part of the HANA site 1. And likewise, I have the HANA site 2 here, which is this one is my this one from here actually is my HANA site 2 master with the SID ADM and the root access, and then my worker node has a SID ADM and a root access, and my worker node 2 in the HANA site 2 has SID ADM and master. And this is the majority maker node here, and then I have the SBD VMs also running in here. All of the SBD VMs are up and running. I can see here they all logged in, and the HANA site master also I can log in and I can see all of this. There's a test VM I have, but I don't have it up and running for now, so we can ignore that at this point. The key thing also I wanted to talk about, let's go through the and let's make this a little bigger. So I'm going to show you the thing. So what I've done is that, as you can see, that there's an SAP CD I have where I have all the SAP software, and this is one I have kind of mounted across all the nodes. All my HANA nodes have it, so that when I was installing the HANA software, I could just mount, this run the software from here when I was installing the configuration. The other thing to note is that for all of these directories, right, the HANA shared, the log, the data, and the user SAP, what I have done is that, as I told you, I basically used an ANF volume from the zone, and I went into this volume, I mounted this ANF volume, and I created this directories called HSO shared, log, the data, and user SAP. And then I mounted these directories directly onto these mount points: HANA shared, HANA log HSO, data HSO, and user CPU. As you can see, this HANA shared is mounted across all the three nodes of HANA site 1. So the key thing to note is As you can see in this architecture, we let me bring this up. Actually, it'll be helpful. So in a sense, what I'm talking
by
about.
the way, Holger, how are we doing on time? I know there's some time constraints on your recordings as well.
Yeah, let's try to. I mean, Abbas, it's very clear. I can see how you know everything inside out here. So this is really fantastic, and I think now we are actually getting to some really also exciting things. But maybe we can try to wrap it up in a few minutes.
Okay, we'll do that. Okay, so here, as you can see, that the HANA shared is mounted across the 3 nodes. So that's what we have done. But the HANA data and the log are mounted individually on each of these nodes. So data and log are separate volumes that get mounted onto data 1. Sorry, to the master here, and the workers have their own individual data and log volumes. And likewise on the other side. That's what I was trying to kind of highlight in here. So that's what you have is that. And if you go to the second node here, for example, and if I do that same command, you would see that
Can you
I
again
would have.
zoom in a little? Sorry.
Yes,
Yeah,
yes, I
perfect.
would. I
Thanks.
mean, so you can see here that the HANA and data are individual volumes that are mounted from this data MNT002 here and log MNT002 on the worker node 1. I mean, likewise, the worker node 2 will have it as MNT0003 and log MNT003. So there's separate volumes for data and log for all the nodes. The HANA shared is the one which is shared across the 3 nodes in HANA site 1, and likewise on HANA site 2, there's a separate HANA shared which is mounted across the 3 nodes on the HANA site. So let's quickly look at the HANA site 2, one of them at least, so we get a clear idea. So if I do here, I'm going to just increase, as you said, let's do this. And if I do a df minus h here, you can see here that the HANA shared here is coming from the zone 2 here. Now, the zone 2 HSO shared this is where it's mounted across all the 3 nodes. In the HANA log and data log, you can see MNT001 and MNT 001, and likewise if I go to the second node real quick and do this, and if I do a df minus h, you can see that the HANA and log are separate. They are HA as well as this prefix, and they're going as log MNT002 and HA data MNT002. And if I go to the third one real quick and do this, you can see here they are going to be HA HSO data MNT003 and HA HSO log MNT03. So these are separate dedicated ANF volumes for data and log across all the nodes. The shared, of course, as I said, is going to be shared across the HANA site. In this case, HANA site 2, all the 3 VMs are sharing this over here. And the user SAP also, we created one that is dedicated to each of the individual VMs. With that, I think what we want to kind of show you is some of the configuration settings, right? I mean, which are important. So let me do one thing for my architecture. Is that I'm going to go to this one over here to actually show you CRM status. So what this does is going to show you how the configuration is laid out. So if you can look in here, we have a 7-node cluster. We keep talking about this. The SpaceMaker sees it as a 7-node cluster. So here, if you look at this configuration, it's showing that the node list, all of them are up and running. So you can see all the 7 nodes are up and running. The Stoneit SBD is a pacemaker cluster resource that can get started on any of the nodes. It's just so happened that it is started on this first node over here, and that's why you're seeing it over here. It's started on the first node. Then you have this file system check resource that runs only on the HANA nodes. So all of the 6 HANA nodes, this resource is started, and it's always stopped on the majority maker. And then there is a HANA topology resource as well, which is this one, and this basically gets started on all the HANA nodes as well. So you can see all of it's running on all the 6 HANA nodes, and it's stopped on the majority maker. And then you can see there is an MSL. This is really the resource which kind of helps start the database on a specific HANA node, and it monitors that. And you can see that it's actually depicting here that it started the master. The primary master is your HANA S1 DB1. So it's really the site 1, which is the master, and your site 2 is really the secondary. In this case, so HANA site 1 is the primary. I want to say, and then of course all the remaining HANA nodes, it just kind of depicts as slaves over here. That's how it does it. I mean, and so even though the HANA S2 DB1 is a secondary master node, it just the way the pacemaker cluster depicts it over here, but it's really in essence a secondary master, the HANA S2DB1 in this case. The other very important thing, of course, is this isn't stopped on the majority maker. The key thing I want to show is the resource. This is the IP resource. The IP resource, you remember that IP address I was talking about earlier, which was 10.0.10.50? That actually is running on HANA S1DB1. And the port number 62503, that is being listened to on this particular node, S1DB1. So if I were to go on this particular node, and in fact, I am on this node, HANA S1DB1, and if I do this IP space A, you can see that 10.0.10.50, which is also the load balancer IP. If you recall, when we were doing this in here, the load balancer IP I was showing you was the front-end IP. And let me bring this a little bit here. And if I go to the load balancer configuration front-end IP, this was the 10.0. This is the IP address. That IP address is in the CRM config. I'm going to show that in a minute. And is also listened to on this particular, wherever the master is. This one is the master. This resource is basically saying that IP address is running. So if I go to an IP space A, you can see that this 10.0.10.50, which I was showing you, is actually running on this particular node. And even the 62503, if I do that, you will see that if I do a telnet, if telnet is operational, 10.0.10.50, 62503, you can see that it is listened to on this particular node, and that's how it is. Where is this configuration stored? If I go into CRM config, show, you can see in things, this is the CRM configuration. And if I scroll on this one, first of all, it's showing you what are the nodes are. All the 7 nodes are being shown here. It's showing you where are these things running and whatnot. I'm going to ignore this here. I do have the automated register equal to true, and what it basically does is that whenever you perform a failover, it's automatically going to reestablish the reverse replication from the new primary to the old primary. That's what it does. Now, typically, customers would not set this to true. They would always have it as false because they want to have control over whenever the failover happens. They want to validate some things and make sure that they set up the reverse replication. But for the demo purposes, you can have this set to true, and that's what I do. And maybe some customers are bold enough to do it. The other thing is this resource, IP address resource. That's what we were talking about. And as you can see, it's actually having this 10.0.10.50 show up here. And if I scroll down, you can see the port number also 62503 show up here. These are configurable parameters. If you were to kind of change your load balancer web for whatever reason, you want to change this from 10.0.10.50 to 10.0.10.55, the load balancer front-end IP, then you will have to come back and change this value here in this CRM config as well. So they wanted to kind of show you this, and I think everything else in here is all good. And I think I will skip the other settings for the interest of time. So I'll just go Control Q. So, okay. Then the next thing I wanted to show you was the global configuration. So real quick, I'm going to go into the global configuration. Okay, before that, let me do this. Keep in mind, if I'm running the landscape status command on any of these nodes on HANA Site 1, let's say if I run this, it's going to show me that all the database nodes are up and running, they're healthy. This is the master one, and the other 2 are worker nodes, and it's going to show that everything is yes and active and good. And likewise, if I run the same command on my secondary site, the HANA Site 2, if I run this command, and I'm going to go a little bit big, it's going to show you that everything is good and nice, and it does depict that this is the master in the secondary side and these are slaves. But this is the secondary side, and which is up and running healthy. Now, if I run the replication status command, which I'm going to run, and I'm going to run this from the master from the primary side. So I'm going to go to the primary side, and if I run the replication command, you can clearly see that it's basically showing that the replication is set up and it's running from HANA S1 DB1. It's going to this HANA from site 1. You're replicating to the site 2, HANA site 2. Over here, everything is sync and everything is yes and everything is active and all that. Now, what we are going to do is that we're going to quickly look at the global.ini file, and then we will perform a failover as well. So let me go through to show you how and the global.ini file will be a separate file for HANA Site 1 and HANA Site 2. So really quick, I will go in here and I'll show you the global.ini file and some key things to look at this. In the global.ini file, Here's what you're basically for your internode communication, you're depicting what internal network to use. And this is the internode subnet network that you will show over here. And then if you're going in further, we do have the HANA checks, that have been enabled, the HANA SR multi-target check and the HANA SUSE check server. The advantage of this check is the second one is that whenever an index server crashes, or instead of the default behavior of restarting the index server on the same the primary master node, which is current primary master node, it's going to actually perform an immediate failover and go to the new primary node. And that is helpful, especially if the database sizes are very large, because you don't want it to try to start on the same node and it just takes forever and you can delay your failover, so you rather want the before behavior to immediately fail over to the other node. This communication is talking about the internal, communication that is happening. Then there are further node. You see that for the client traffic, this is the public host name resolution. This is all of the client traffic is coming on this and on these nodes. It's showing you. And then another thing to note is in here, which is of importance, is the base path share you have to set it to no, and you got to provide the data and log volumes. But other than that, and the links provide all the details. The key thing to note is this is the IP addresses you'll use for your HSR communication. So you're basically saying in here that your system, when a system application should happen on the IP addresses that belong to the HSR subnet, or that's what you're saying in here. So all of these details are in this global.ini file. And real
now
quick,
show us the failover.
okay, got it. So let's do that. So we'll stop here and we will do, so going back to CRM status, this is how your status is. And we're going to do a resource, move, and we're going to move this node and we are going to do force. So once you do that, keep in mind, you're on HANA site 1. So this is HANA S1 DB1, and we are going to basically fail over to HANA site 2 by running this command. And before this command run, the key things to note is that you want to do a CRM config show and grep for any location constraints. There should not be any, like you can see, I have a location constraint here, which I want to clear. So I'm going to clear any location constraints on this particular resource. So I'm going to do this. So it's because I don't want anything. So now when I run this command, grep CLI, because most customers forget after performing a failover to clear the constraints. So because if you have a constraint, it will not be able to go. Sometimes there's a CLI prefer constraint you get if you're not using the force command. And if you're doing a force command, it gives you a CLI ban constraint. I'm going to show you that in a minute. So that's what it was. And then I want to make sure that CRM, resource cleanup as well, just to make sure everything is clean. And then CRM status. And now we will do a resource move because everything is clear. I am going to move this and typically you can provide the node name and force, or you can just directly do force as well. It's fine where you're going to. And when you run this, now it did create a constraint here, and I'm going to show you if I do CRM mon-r, we would be failing over from S1 DB1 to S2 DB2. As you can see, the IP address and the port automatically have now started on the HANA site 2 DB1s.
Yeah.
And now it's stopping the HANA database on S1 DB1. And once it stops the database on S1 DB1, it's going to promote the database onto the HANA S2 DB1. So it's going to, it's promoting, you can see here now, it stopped the HANA database on S1 DB1, it's promoting the database now. And once it promotes the database, it's going to make that database the master.
Perfect.
And if Abbas, once this is set up, this is all automated through Pacemaker, right? There's no human intervention. If there's some issue with HANA, Pacemaker has intelligence to detect it and do the failover.
Absolutely, yes. And then the Pacemaker cluster will kind of, make sure that it brings its whole job is to make sure that it brings the cluster in consistency and has, one of the sites as primary and another site as secondary.
Perfect.
Yeah, and I think it'll take a few minutes for it to come up, and it's almost there now. Almost in the next second, you can see now we have the master here with HANA S2 DB1 up and running, and everything else is a slave. And then everything has failed over as expected and is running. Now, if I were to go in and if you were to give it a few minutes, it's going to reverse establish the replication for me as well, and we can show you that the reverse replication is established, and you can perform a failback also if you got a few minutes. Up to you.
I would say, Abbas, I would leave it at here. I mean, we saw the failover basically, so I think that's already fantastic. And honestly, I really love the way how you build up everything, how you started with the configuration on the Azure side, and then also showed the configuration on the system itself, basically. You said you are working on a white paper that will outline all these steps, so I think that's really great.
Yes,
I think once the white paper is released, maybe we can take another closer look at the results and maybe play around a little with the failovers, fail back and forth. But I think for this first session, if you don't have anything other major to show, I would suggest that we wrap it up now. And then I mean, we saw this scenario, we saw that it is working, or hopefully.
Yeah, it takes time to reestablish your application because it needs the second site to be up and running. So we got to, in the interest of time, we can stop, I guess. And the one last thing I wanted to kind of just quickly explain this, is if I were to go on here and just kind of, Control C and do this. I mean, so there is this corosync.conf file. At the very bottom there is the quorum setting. You can see here in this, in a 2-node cluster, when you're using like HANA scale-up clusters, when you have only 2 nodes, like the primary and the secondary node, and we don't have any majority maker over there, we depict those clusters with 2 nodes. We put the value as 1, and that's a special designation provided to a HANA scale-up 2-node cluster. Typically in a scale-out architecture, you can see the value is set to 0, and then expected votes are set to 7 here, which basically is saying that this is not a 2-node cluster. This is a 7-node cluster.
This is 7, yeah.
That's what I wanted to kind of show. And I think with that, I think we can go back to this one, and which shows the whole that everything is failed over and looking good. I think we can close the session out, if you will.
Always pretty neat to see the architecture from PowerPoint to implementation.
Absolutely,
and really see it work. It's pretty neat to see the
absolutely.
So.
Going from the PowerPoint slides to here is absolutely amazing. And Abbas, I mean, it's clear that you know this inside out. So thank you so much.
I think, to be fair, I mean, like Momin and me did this together, and I think this is a collective effort. So I appreciate that.
Absolutely. Yeah.
Well, Momin, Abbas, thank you so much for this. That was really insightful and really interesting. Sorry for rushing you at the end. And I mean, I'm really excited. So maybe once the white paper is released, maybe we can really have a follow-up to take a close look, not at the initial configuration, but really then here at the results and playing around a little here with the settings.
Absolutely.
Yes. Yeah.
Cool. Well,
great. Thank you
so much, and thank you for the opportunity.
Thanks for the opportunity. Holdran, I'm waiting for the chicken tandoori review from you. So
yes,
I will hold you to
you'll
that.
get that, absolutely.
I should stop sharing.
Great. Yeah. Thank you, everyone.
Yeah, thanks everyone.
And
Take
we'll
care.
definitely see you again.
Absolutely.
Okay. Look forward to it.
Thank you.
Thank you.
See you, boss. Take care.
See you
Thanks,
then.
guys.
Bye.
Yeah.
Thank you.
Bye-bye.